VBT. And you know the full form of VBT? Valence bond theory. Valence bond theory given by Mr. Pauling and Slater. And you know one more important thing, the basis for valence bond theory is the concept of electron pair bond given by Lewis. And see here, in the valence bond theory, we are going to learn the directional property of the bond and overlapping of atomic orbitals in the valence shell. Let us start the session with a few important numericals and important points related to valence bond theory, one of the important concept for our JEE and NEET. Let us start. Let us start the first one. Most important concept of valence bond theory is option A, overlap of atomic orbitals results in the bond. Option B, sharing of odd number of electrons for bonding. Option C, sharing of electrons follow the octet rule. Option D, transfer of electrons follow the octet rule. Valence bond theory explains the overlapping of two orbitals. Option A is correct one. Let us check the second one. Which of the following overlap is the strongest? Option A, sigma 2p 2p, sigma 3p 3p, sigma 5p 5p, pi 5p 5p. In the given option, they gave sigma 2p 2p, sigma 3p 3p and sigma 5p 5p and one more is pi 5p 5p. And here you have to understand one thing, increase in the shell number, the size of the orbital also will increase. And here one more important thing, increase in the size of the orbital, the overlapping decreases. Here valence bond theory, it is related to overlapping of the orbitals and extent of overlapping decreases with increase in orbital size. That's why here option A, sigma 2p 2p is the strongest one because it has more overlapping. We will start third one. The directional nature of covalent bond was introduced by option A, valence bond theory, option B, causal and Lewis theory, option C, hybridization theory, and option D, Vesper theory. The directional nature of covalent bond was explained by the valence bond theory given by Pauling and Slater. Fourth one. According to valence bond theory, water molecule has option A, two dative bonds and bond angle 90 degrees. Option B, two covalent bonds and bond angle 90 degrees. Option C, two dative bonds and bond angle 104.5 degrees. Option D, two covalent bonds and bond angle 104.5 degrees. In the given question, they are asking number of covalent bonds and bond angle between those. And here it is very important because in case of hybridization, the bond angle is different. In case of overlapping, the bond angle is entirely different. Here, in case of valence bond theory, we are just talking about the overlapping. See here, in case of what is the molecule given to us? That is water molecule. In the water molecule, oxygen has two unpaired electrons. The two unpaired electrons are present in two p orbitals. And see here, these are two p orbitals of oxygen and two hydrogens are going to bind with this one. And see here, one unpaired electron in one p orbital, another unpaired electron in another p orbital. Now, one orbital of hydrogen, that is s orbital of hydrogen with unpaired electron combines here, and one more hydrogen orbital with one unpaired electron joins here. And observe here, the p orbitals of oxygen and s orbitals of hydrogen overlaps like this. And if you observe the bond angle here, it will be 90 degrees. Very important thing. In case of hybridization, the bond angle is 104.5 degrees. That is a different case. There Vesper theory will work. Lone pair repulsion, lone pair repulsion. Few more things are there in, we will discuss in that one. But here only overlapping, and that overlapping takes place at 90 degrees with the both s orbitals of hydrogen. Okay. Option 2, that is 2 covalent bonds and 90 degrees is the correct answer. Fifth question is based on the possibility in overlapping. We will check that one. Zero overlapping is present between option A px px, option B px py, option C s and s, and option D dxy px. Let us check the 4 options one by one. See here, first one, the overlapping between px and px. See here, if you take px of one atom and px of another atom, what will happen? Side by side overlapping takes place. Overlapping takes place here. Means here the possibility of overlapping is there. They are asking in which case zero overlapping. Zero overlapping in the sense there is no overlapping. In case of px and py, px and py. See here, it is on x-axis, it is on y-axis. These two are present on two different axes. That's why the overlapping is not possible. Okay, overlapping is not possible between px and py because they are present on two different axes. That's why it is not possible. Okay, let us check this one. S and s orbitals. See here, s orbital and one more s orbital. See here, s and s orbitals, they overlap on each other. Here no problem because both the s orbitals are non-directional ones. That's why no issues in case of s and s overlapping. And here one more important thing, maximum overlapping is possible in case of ss overlapping. That is also one of the important point. SS overlapping is possible. Next we will go to option D, dxy and px. See here, in case of dxy, you remember that one, the orbitals are present in between the axes. Okay, if it is x and y, these are present in between the axes. And see here, we will take px, between px and dxy, side by side overlapping takes place, which leads to pi bond formation. And see here, in case of px pi bond formation, and in case of ss sigma bond, direct overlapping is possible. That's why sigma bond will form. And in case of dxy px, side by side overlapping takes place, that leads to pi bond formation. Means here in case of option A, C and D, overlapping is possible, but here question is based on zero overlapping. Zero overlapping in the sense no overlapping. Then our answer is option B, px py. Valence bond theory is one of the important concepts. Just now we discussed a few important examples for that one. And here you have to keep a few things in your mind. That is, valence bond theory explains the overlapping of valence bond orbitals with unpaired electrons. And see here, sometimes there are no unpaired electrons, paired electrons are there. In such cases, the orbitals with paired electrons gets excited and it will get unpaired electrons. After getting unpaired electrons, it will overlap. And very important point is, the overlapped orbitals have only unpaired electrons. That is very important point. And here one more important thing is, in case of direct overlapping, sigma bond is formed. In such cases, in case of sigma bonds, in case of sigma bonded overlappings, the electron density is present along the internuclear axis. Okay, that is very important thing. And side by side overlapping leads to pi bond formation. Sigma bond is direct overlapping, that's why it is strong bond, whereas pi bond is side by side overlapping, or you can say lateral overlapping. That's why pi bond is weaker than sigma bond formation. And always one sigma bond is formed, and sigma bond is always independent one, whereas pi bond is always a dependent one, where it will be formed when there is a sigma bond. Okay.